question is question 8. A fish shop has a vertical sign outside its front door. In the diagram below, the sign is represented by the line segment FH with the line segment FH equal to 3 meters. So that's it here. A cable is tied at the top of the sign and is secured at a point G on the horizontal ground. G is 1.4 meters from the base of the sign H as shown in the diagram below, which is not to scale. Use the theorem of Pythagoras to find the length of the cable GF. Give your answer in meters correct to one decimal place. So we've got to use Pythagoras' theorem. So that's just going to be 1.4 squared plus 3 squared equals the length FG, which we've got to square. So 1.4 squared is 1.96, 3 squared is 9, and that's equal to FG squared. FG squared is equal to 10.96, and what we've got to do then is just square root both sides. So the distance from F to G is just the square root of 10.96, and we've got to do this to one decimal place, so it is 3.3 meters. Okay, so let's look at part 2. Show that the size of the angle FGH is 65 degrees to the nearest degree. So FGH is this angle here. So what we're going to do is we're going to call this the angle FGH, and we're going to get the tan of that angle, which is opposite over adjacent, which is 3 over 1.4. So let's do that. So the tan of the angle FGH is equal to 3 over 1.4. So that just means that the angle FGH is equal to tan inverse 3 over 1.4. So that means finally then that our angle FGH is equal to the nearest degree is 65 degrees. The nearest degree. Okay. Next one then. A second cable from G is tied to the sign at the point K, where K is halfway up the sign FH. And they show that here. There's FH, which was 3 meters, and K is where the new cable is tied. Mairead says that the size of the new angle KGH is half the size of the angle FGH. Is Mairead correct? Use calculations to support your work. So you've got to calculate this angle here now and see is it half of what we got before. So let's do that. So it's the same kind of thing again. We're going to say the tan of the angle KGH is equal to, this time it's going to be half, it says it's halfway up, so it's going to be half of 3, which is 1.5 over 1.4. So it is 1.5 over 1.4, so that just means then that the angle KGH is equal to tan inverse 1.5 over 1.4. So the size of the angle KGH is going to be equal to 46.97 degrees and so on, which is not equal to half the angle FGH. So the answer here is that Mairead is incorrect. Okay, so now we have the fish shop has a logo with some measurements as shown in the diagram below, not to scale. AB is 12, AC is 10, the angle ABC is 37. Work out the size of the angle theta, where theta is the angle BCA. Give your answer correct to the nearest degree. So we're looking for BCA, we're looking for this angle here. So we're going to look at this triangle here. We have two sides, we have an angle opposite one of the sides. It's not an enclosed angle, it's opposite to the 10 centimeters. So what we're going to do here is use the sine rule. We're going to say sine of 37 over 10 is equal to sine theta over 12. Or we can just say sine theta over 12 is equal to sine 37 over 10. Now here we've got a fraction equal to a fraction, so you can cross multiply. So we're going to say 10 sine theta is equal to 12 sine 37 degrees. That just gets rid of the fractions. We want to find theta, so I've got to get sine theta on its own. So that's 12 sine 37 degrees divided by 10. Now when you do that, 12 sine 37 is over 10. When you do that on your calculator, you get 0.722178. So all we've got to do now, remember this is sine theta, so to find theta then we just do sine inverse of 0.7221780278. When you do that on your calculator, you get theta is equal to the nearest degree again is going to be 46 degrees. And that's to the nearest. That's just to the nearest degree. Okay, so let's move on to part 2. CF is equal to 22, EF is 11.8, and the angle EFC is 110. Use the cosine rule to find the distance CE. Give your answer correct to one decimal place. So we've got to find the distance CE. So we've got to find the distance from here to here. This time we have two sides and an enclosed angle. When you see that, you can use the cosine rule. So we're going to say this side squared is equal to this side squared plus this side squared minus twice this times this cos this here, 110. So let's write all that out. So the side CE squared is equal to 22 squared plus 11.8 squared minus twice 22 times 11.8, and then it's cosine of 110 degrees. So you just got to work all this out on the right hand side. So CE squared is equal to 623.24. That's these two here done. Now I'm just going to do these three here. Going to multiply those three out, and that'll give me 519.2. If you get the cosine of 110, that'll give you minus 0.34201433. And let's see, if we do all of this, you get CE squared is equal to 800.8168584. Okay, so we've got to find CE then. So this finally gives us CE is equal to the square root. You've got to square root both sides. We've got to do this to one decimal place. So it's going to be 28.3 centimeters. And this is to one decimal place. Okay, so that was part 2. Let's have a go at part 3. CDEF is symmetrical about CE. Work out the total area of CDEF. Give your answer correct to the nearest square centimeter. So CDEF is symmetrical around CE. So what we've got to do here is find the area of one triangle and just double it. So what we're going to do here, again we have two sides and an enclosed angle, so the other thing you can do with that is find the area of a triangle. So it's going to be half of 22 multiplied by 11.8 sine 110 degrees. So the area then of CDEF is going to be twice half AB sine C. So it's going to be half A, which was 22, B, which is 11.8, and then we've got sine of 110 degrees. So that's what we've got to do. So twice a half, if we just do this bit here, is just 1. So really all you got to do is multiply out those three things there. When you do all of that, correct to the nearest square centimeters, which is what we have to do, you get 244 square centimeters. And that's it for this question. Okay, so let's have a look at question 9.